Section 3.5, Graphing Techniques, Transformations. All right, this is what we're going to be doing in this section, okay? You are going to be given some kind of basic function. That basic function may be one of the basic functions you learned in section 3.4, like f of x equals x, or x squared, or the absolute value of x, or the square root of x, or x cubed, or the cubed root of x, okay? Or it could just be a random basic function. And what you're going to have to do with that basic function is transform it. And what a transformation is, that just means you're taking the basic function and you're either going to move it up, down, left, right, or do some kind of reflection. You could reflect it about the x-axis or about the y-axis or about the origin. Other transformations, you could do a horizontal stretch or a horizontal compression, or you could do a vertical stretch or a vertical compression. Okay, so basically you are taking a basic function and you are doing some kind of transformation to it. Okay, so in this section, we're going to learn the transformation rules. Okay, let's get started with example 1. Okay, it says plot the graph of f of x is equal to x squared on the grid below using what you learned in section 3.4. For each remaining function, construct a table of xy values. Tables are provided on page 2, and use the points found to sketch the graph of the function. Graph all functions on the grid given below using a different color for each function. Okay, and it says color pencils are provided. That's in the event that we have class in person. Okay, so let's take a look at this example. It spans a couple of pages here. So what I have here is a list of 5 different functions. Okay, we've got f of x is equal to x squared, g of x is equal to x squared plus 3, h of x is equal to x squared minus 5, j of x is equal to the quantity x plus 4 in parentheses squared, and then finally k of x is equal to the quantity x minus 2 squared. Okay, then there is a grid. Okay, if you go to page 2, okay, you will see a table of values. There's a separate table for each of the 4 functions. The first one is x squared. We know what that looks like from section 3.4, but the other 4 functions, we have to make a table of values to plot them. So you can make your tables on page 2, and then once you come up with your list of points for each graph, you can come back to the grid, and we're going to put all the graphs, all 5 graphs on this one grid. Okay, essentially what we're doing here, okay, if you notice, okay, x squared is the first function, that's f of x. That's the one we're familiar with. It is the basic function we learned in section 3.4, okay. The other 4 functions are some variation of x squared, okay. If you notice, like parts B and C here, functions G and H, you're basically adding or subtracting to or from the x squared quantity, and then the last 2 functions in parts D and E, functions J and K, basically you've got parentheses involved, but it involves a quantity squared. Okay, so if you were to multiply out, if you did, if you distributed, you did like in part D, if you did x plus 4 times x plus 4 and you multiplied that out, you would get an x squared piece in there. Okay, so the remaining 4 functions are some variation of x squared. We're comparing them by putting them all the graphs on one grid, so we can see how the 4 functions compare to the original basic function of x squared. Okay, so let's begin by graphing f of x is equal to x squared. Okay, we know what this looks like from section 3.4, like I've said. Okay, I'm going to go ahead and put that one in black. Okay, so we know that x squared is going to be a parabola. It goes through 0, 0. It goes through 1, 1. It goes through 2, 4. And it goes through 3, 9. okay? It is symmetric about the y-axis, so it's also going to go through negative 1, 1. It is going to go through negative 2, 4. It's going to go through negative 3, 9, okay? And then I'm going to go ahead and connect the dots using a parabolic shape here. So give me a second to draw this in. All right, and remember, it goes up forever in this direction, and it goes up forever in this direction. So you need to put arrowheads on the ends here. So this is f of x is equal to x squared. Okay, this is our basic function. Okay, so now what I'm going to do is I am going to go to the second page, and I am going to start making a table of values, okay, to come up with a list of points so that we can plot each of these other 4 functions on the same grid. Okay, so if you look at page 2, okay, there is a table of values for each of the 4 remaining functions. Okay, so I am going to go ahead and pause the video. Okay, I'm not going to bore you with the details. I am going to pause the videos and make the table for each one of these 4 remaining functions and plot the points. Okay, and then I will resume the video. All right, I'm back. So first, let's talk about the tables. Okay, I have completed all 4 tables, so hopefully you have done the same. If we start with g of x, which is x squared plus 3, remember you can rewrite that as x times x plus 3. So I basically chose the standard x values. I chose x values from negative 2 to 2. So again, you would just plug in each x value. You would take each x value, multiply it by itself, and then add 3. So I have a list of points out to the left here that fall upon this graph. And then I went ahead and plotted it. Okay, so I'm just going to quickly go through each of the tables and then we'll talk about the graphs. Okay, and then if you go to the next table, meaning let's look at the table of values for h of x is equal to x squared minus 5. Again, that is the same thing as x times x minus 5. I chose the same x values, okay, negative 2, negative 1, 0, 1, and 2. You would just take each x value, multiply it by itself, and then subtract 5 from the result. Okay, so again, I end up with 5 good points to plot. Now keep in mind, okay, when I was doing this, I'm trying to make sure that my graph fits on the grid that has been given, okay? So if you made a table of values yourself, you may have encountered a problem when you got to the other 2 functions. So let's take a look, okay? If looking at j of x is equal to quantity x plus 4 in parentheses squared, if you had chosen the same x values, negative 2, negative 1, 0, 1, and 2, you would have ended up with y values that don't fit on the grid. Okay, so what you needed to do was kind of play around and come up with x values that, you plug in, you're going to get a y value that will give you a point that will actually fit on our grid. Okay, so if you played around with it, some good x values to use here are negative 6, negative 5, negative 4, negative 3, and negative 2. Okay, make sure you pay attention to the order of operations here. When you evaluate this function, you need to plug in your x value, add 4 to it first, and then simplify the number in parentheses and then square that result. So for example, if I use x equals negative 6, okay, if I plug that in, I'm going to get negative 6 plus 4 in parentheses. That's the quantity that's going to be squared. So negative 6 plus 4, I would do what's in parentheses first. That is going to be negative 2 in parentheses. That's the quantity that gets squared. Okay, the negative is inside of the parentheses, so it will get squared as well. Negative 2 times negative 2 gives you positive 4. Okay, that's how you want to work with this particular function. And if you used these x values, here are the points that you come up with. Okay, the same thing happened when you tried to work with k of x. which is the quantity x minus 2 in parentheses squared. Okay, again, you have to figure out what x values work here so that if you plug in each x value, you end up with a y value that will fit on our grid. Okay, so here the good x values to use are 0, 1, 2, 3, and 4. Okay, you have to work with this function the same way you would work with j of x. Okay, you need to follow the order of operations. So when you plug in an x value, you need to first simplify what's in parentheses and then square that result. So for example, if you work with x equals 0, okay, you would plug that in, you would get 0 minus 2 inside the parentheses, and then you'd have to square that. Okay, so then you simplify what's inside parentheses. 0 minus 2 is negative 2. That quantity gets squared. Negative 2 times negative 2 gives you positive 4. Okay, so this is how the tables were constructed so that you can actually, fit each of these graphs on our grid. Okay, notice they are color coded. Okay, I did each table in a different color, and now we're going to return to the grid where we have all 5 functions graphed, and whatever color the table is in, the corresponding graph is in the same color. Okay, all right, so I'm going to go back to the grid. Okay, I basically took went to each table, took my points from each table, and plotted the corresponding function. Okay, so I've got each function in a different color corresponding to the table of values, and I wrote the formula for each function out to the side. Okay, so you can see what is going on here. Okay, remember the basic function that we're starting with here is f of x is equal to x squared. That is the basic parabola that is in black. Okay, and what you should notice from this is that the other 4 graphs have the exact same shape. They have just been moved around. Okay, so what we're going to do now is we're going to go to each of the 4 functions and compare. How did it get moved around in the xy plane compared to the original x squared function? Okay, so if you jump over to page 3, okay, there is some fill in the blanks here. Okay, we're going to compare graphs. Okay, so let's look at the first bullet point. Okay, it says g of x equals x squared plus 3 is the graph of the original basic function f of x equals x squared shifted how? Okay, so let's go compare those 2 functions. So let's return to the grid. Okay, we are comparing the original function in black to g of x, which is the blue function, x squared plus 3. Okay, a good way to compare, okay, when you're dealing with a parabola, it is a U shape. So you're going to look at the low point. Okay, if I look at my black original graph, the origin, that's the lowest point on the graph. For a parabola, when we study parabolas, you will learn that the high point or the low point of a parabola is called its vertex. So just compare the vertex. Okay, where did your vertex start and where did it end up? Okay, so again, we're comparing the black graph to the blue graph. Okay, the original graph is x squared, the black graph. Okay, we're looking at the blue graph. Where did the vertex go? Well, it went up 1, 2, 3 units. Okay, and I would end up at 0, 3. Okay, and notice this is true of every single point on the black graph. If I take the next point on the black graph, so 1, 1, okay, where did that point go to get to the blue graph? Well, it went up 1, 2, 3 units. Okay, same thing. Take the point 2, 4 on the black graph. It went up 1, 2, 3 units. Okay, so if you look at every point on the black graph, it has just been lifted up 3 units to come up with the blue graph. Okay, so notice, okay, let's fill this out first. Okay, x squared plus 3, it is the graph of the original function shifted up 3 units. Okay, now look at this. Look at the formula. Okay, the formula here, we have the original function, the black function, there's x squared, and what we did was we just added 3. Okay, and that caused this vertical shift. It caused us to go up 3 units, okay? That is what's going to happen. If you take a function and then you add a number to it, it's going to cause you to go up by that many units, okay? Now let's take a look at x squared minus 5. Let's compare that to the original function. Okay, so going back to the original grid here, we're looking at the black function and the green function. Okay, the green function is x squared minus 5. Okay, let's compare those two guys. Okay, again, concentrate on the vertex to see what's going on. Okay, the vertex for x squared is again at the origin. Okay, where did the vertex go for the green graph? Well, we just took the origin here and we went down 1, 2, 3, 4, 5 units. Okay, again, you can check other points on the black graph. You're going to see the same kind of thing. If I look at the point 1, 1, where did it get transformed to? Down 1, 2, 3, 4, 5 units. Okay, if you look at the point negative 1, 1, where did it go? Down 1, 2, 3, 4, 5 units. Okay, so basically to come up with the graph of x squared minus 5, the original graph x squared just got shifted down 5 units. Okay, so let's go write that down. Okay, so h of x is equal to x squared minus 5 is the graph of f of x is equal to x squared shifted down 5 units. Okay, again, if you compare the formula, okay, look at the equation for h of x. It is the original function x squared. This time we're subtracting a number. Okay, so if you subtract a number, that forces you to go down. Okay, now make sure you keep it straight. Look at g of x and look at h of x. Okay, in g of x, you added a number, so you went up. In h of x, you're subtracting a number. Okay, that makes you go down. Okay, all right, let's take a look at j of x. Okay, so now we're going to compare j of x is equal to x plus 4 quantity squared. Okay, how does that compare to the original function? Okay, so j of x is going to be the graph that I have in purple. Okay, so again, we've got two parabolas here. It's basically the same black shape that's just been moved around. Okay, compare the vertices. Okay, where did the vertex of the black graph go? Okay, so the point 0, 0 has been transformed. The vertex of the purple graph is at the point negative 4, 0. Okay, so basically we went 1, 2, 3, 4 units to the left. Okay, and if you look at other points on the black parabola, you will see the same thing. If I take the point at 1, 1, where did it go? Well, 1, 2, 3, 4 units to the left, okay, to end up at negative 3, 1. Okay, if I take the point at 2, 4, it went 1, 2, 3, 4 units to the left and ended up at negative 2, 4. Okay, so to get our purple graph, basically the black graph was shifted over to the left by 4 units. Okay, so let's go ahead and fill that out here. Okay, so let me get my pen color ready here. Let's go write this down. J of x is equal to x plus 4 quantity squared. It is the graph of x squared shifted left by 4 units. Okay, so let's talk about the formula. Okay, when you were doing up or down, you just took the basic function and you either added or subtracted a number. There were no parentheses. Okay, now there are parentheses involved. When there are parentheses involved, that is going to cause a horizontal shift instead of a vertical one. Okay, so what we have here when we're looking at the equation for j of x, we've got x plus 4 in parentheses. Because of the parentheses, we know we're going either left or right. Okay, we went left here, so notice what's going on. If you add inside parentheses, that's going to cause you to go left. Okay, and you're going to go left by the number of units that's inside the parentheses. Okay, so you're adding 4 inside the parentheses, that causes you to go left 4 units. Okay, finally, let's compare x squared to the graph of x minus 2 quantity squared. Okay, so go back to the grid over here. We're looking at the red graph, the red parabola. Okay, that is x minus 2 quantity squared. Okay, Again, we have another horizontal shift. If you compare the vertices, the original function x squared has a vertex at the origin, okay? The parabola in red has its vertex at the point 2, 0, if you can see where my cursor is. So basically, we have shifted over to the right by 2 units, okay, to get that new vertex, okay? And the same is true of every point on the black graph. If I look at the point 1, 1, it has been shifted 1, 2 places to the right to end up at 3, 1. If you look at the point -1, 1 on the black graph, it has gone over 1, 2 units to end up right here at 1, 1. Okay, so basically here, our original graph has been shifted 2 units to the right. Okay, so let's go ahead and fill that in. We have shifted right 2 units. Okay, and again, the formula is very telling. Okay, when we look at k of x is equal to x minus 2 quantity squared, we have parentheses that tells us it's going to be a horizontal shift. Since we are subtracting, we are going to go to the right by that number of units. Okay, so basically from this example, okay, this is kind of showing us the rules for vertical and horizontal shifts. Okay, so if you have your original function and you add a number and there's no parentheses, the basic function, the original function is going to go up by that many units. Okay, if you have your original function and you're subtracting a number and there's no parentheses, the original function is going to shift down by that number of units. Okay, if you have your original function, okay, but basically now you've got parentheses, okay, so when you look at j of x, remember x squared is still involved, it's a quantity squared, okay, but now you've got parentheses. So if you've got parentheses, that's indicating a horizontal shift. If you're adding inside the parentheses, you're going left by that many units, and if you are subtracting inside parentheses, you are going right by that many units. Okay, below this example, okay, I've got a summary of vertical and horizontal shift rules. Okay, so let's quickly read through this. Okay, it says in the first box, it talks about vertical translations. Translations just means a shift. Vertical means up or down. It says a vertical translation of the graph of y equals f of x is a shift of the graph either up or down in the coordinate plane. Okay, so then it says c is a number. Okay, so basically if you look at this, okay, the way you can read this is kind of mathy, but f of x is your basic function. Okay, so if you take your basic function f of x and you add to it, there's no parentheses, you're going to go up by that many units. If you take your basic function f of x and you subtract from it and there's no parentheses, you're going down by that many units. Okay, on the flip, if you do a horizontal translation, so basically you're going either left or right. Again, f of x is representing your basic function. Okay, so when you look at this, again, it's mathy, but when you look at this, you are now adding inside the parentheses. If you look at this line right here, if you're adding inside the parentheses, that means you're going to the left by that many units. If instead you are subtracting inside the parentheses, you are going to the right by that many units.